Okay, so we did binary compounds. Now we're going to look at ternary compounds. The first type of ternary compound is an oxyacid. Now, I'm not going to follow these rules for oxyacid listed under letter D, but you can certainly do so if you wish. I left all the notes intact, so you can follow those notes under letter D if you wish. However, I prefer a different way to teach oxyacid. So what I'm going to give you, you can write on the back sheet of your notes. I'm going to give you the most common forms for oxyacids. So these are not written down. You need to go ahead and write these down somewhere on your notes. The most common forms end in ic. Now I've given you 11 most common forms. It's important to get the number of hydrogen and oxygen with these correct. So for example, H2CO3 is carbonic. It's got carbon in it. HNO3 is nitric. It's got nitrogen. And so forth. H3PO4 would be phosphoric. H2SO4 would be sulfuric, and so forth. The only one that's got a weird name is this last one here, and this is called acetic acid. Acetic acid. HC2H3O2, acetic acid. So when you're naming oxyacids, it's just a matter of memorizing these 11 most common forms. And then once you get those most common forms memorized, you can either add oxygen or you can subtract oxygen. If you take the most common form and you add an oxygen, you simply add a prefix per and then ic. If you take the most common form and you subtract an oxygen, the suffix changes to ous instead of ic. And then if you take the most common form and subtract 2 oxygen, you get a prefix hypo and then us. So let's go through some examples, and I will use one of the most common forms. Let's just go ahead and use H2SO4 as our example. So H2SO4 is the most common form, that is sulfuric. But what I can do is I can take the most common form and I can add oxygen. So it's possible to have H2SO5. H2SO5 would be called per-sulfuric. I can also take the most common form and subtract oxygen, so I could have H2SO3, which would be called sulfurous acid. And finally, I could have H2SO2. I could subtract 2 oxygen from the most common form, and that would be hyposulfurous. So that's kind of the idea with these acids. You have to memorize those most common forms. So if I say, what is per-phosphoric acid? Go back to your most common form. But since there's a per in front, and since there's a prefix, instead of H3PO4, it's H3PO5. Notice the number of hydrogen does not change ever with these acids. If I have hyponitrous acid, hypo means I've lost 2 from the most common form. It was HNO3. Now it's just HNO1. I've lost 2 oxygen from the most common form. So with the oxyacids, my suggestion, memorize those 11 most common forms, and then the prefixes and suffixes that go along with those. Ternary salts. Ternary salts come from an oxyacid. We simply replace the hydrogen with a metal. So we're going to name the metal first by just giving the metal name. The name of the oxyanion is based on the name of the oxyacid from which it's derived. If the oxyacid ended in ic, we're going to drop the ic and replace it with 8. If the oxyacid ended in ous, we're going to drop the ous and replace it with ite. So let's look at a couple examples of some ternary salts. Again, these come from an oxyacid, simply replacing the hydrogen with a metal. So an example would be Na2SO4. We're going to name the metal first, sodium. The SO4 comes from the acid H2SO4. So go back to your list, your most common forms. H2SO4 is sulfuric, But when you get rid of the hydrogen, the ick becomes 8. So SO4 by itself without the hydrogen is sulfate. So Na2SO4 is sodium sulfate. Let's work the other way. Let's say we have magnesium perchlorate. Put the Mg there. It's got a charge, +2. And the charges are important when we work backwards. Perchlorate comes from perchloric. So I'll go ahead and write that down, perchloric. So I'm going to write down the acid, perchloric. I'm going to add an oxygen to the most common form, so that'd be HClO4. Now, I want perchlorate, so I'm going to get rid of the hydrogen. I'm getting rid of one hydrogen, so the charge is -1 on the ClO4. And that's how I get the charge. Look at the number of hydrogen. So ClO4 is a -1. We have to cross charges, so magnesium perchlorate would be MgClO4 2. Let's do one more. Sodium. Let's do hyposulfite. Okay, sodium, Na. Hyposulfite comes from hyposulfurous acid. So go back to your most common form. Hypo means you lost 2, so this would be H2SO2. That's hyposulfurous. I don't want the hydrogen in a ternary salt. Get rid of that. Now I'm getting rid of 2 hydrogen, so the charge on SO2 is -2. That's how I get the charge. So when I put it with sodium, with that -2 charge, the 2 crosses down. So sodium hyposulfite is Na2SO2. So those are examples of ternary salts where the hydrogen is replaced with a metal. And ternary salts end in ate or ite. You get one more type here, acid salts. Acid salts are derived from oxyacids, but one or more hydrogen atoms remain. And so we're going to insert the word hydrogen or dihydrogen into the names of these acid salts. Let's look at a couple examples. KH2PO4, for example. We're going to name the metal first, potassium. Since there's 2 hydrogen that remain, this is an acid salt, we have to say dihydrogen. And then we name the PO4 portion. Now the PO4 portion, just like before with the ternary salts, go back to the acid, PO4 comes from H3PO4, which is phosphoric, but we replace the ic with 8. So PO4 comes from phosphoric acid, but it's called phosphate. So this would be potassium dihydrogen phosphate. Now let's contrast that compound with this compound. This is an acid salt. It's got a hydrogen left over. The difference is there's 2 potassium instead of 2 hydrogen. We don't say dipotassium, we just say potassium. Since there's only 1 hydrogen, I don't need the di there, so it's just potassium, hydrogen. And then PO4 again comes from phosphoric, so that means it's phosphate. So you see the difference in those 2 acid salts. So if it has hydrogen left over plus a metal, we have to include the metal and hydrogen in the naming. Those are acid salts. Here are some polyatomic ions whose common names persist. NH4 plus is ammonium, OH minus hydroxide, CN minus 1 is cyanide, acetate, and thiosulfate. These are common ions where the common names persist.